Hey, hi. Am I audible? Hello. Yeah, your voice was not clear. Yeah. So have you guys tried the question which I provided from BFS, DFS, and others? I'm not sure why I'm not able to hear you if you are speaking.
Hello, hello.
Yes, now you're audible.
Yeah, uh, yeah. This week I haven't tried.
Okay. Any doubt from the previous session? Anything you want to discuss specifically?
I guess last time you asked how we'll print uh, right view of the tree using DFS, right? So we can use the same
How how we will print what?
right view of
Ah, okay. Hmm.
using DFS. So I guess like the way how we implemented level order using DFS, we can use the same approach. Like whenever we are getting first time on new level, we can add the last node.
Okay. Okay. Let's start from there then. Mhm. Okay, is my skin visible?
Yes.
So I think last time the question was that we are given a binary tree, something like this, and we need to find out the what level order traverse. Sorry, we need to find out the right side, the
Right.
right view or the left view, whatever.
Right.
Okay, so what you are saying, how we can solve this by using DFS? With BFS, it would be very straightforward. How with DFS?
Like the same way we implemented level order using DFS. So whenever the result size is equal to depth, we were adding the we were creating a new list every time, right? At a new depth level. So this time, like at that point when we are adding the creating the list, we were adding the first element, right? When we were traversing from left. Now we'll just start traversing from right, and we'll add the first element, that is 3. Are you getting what?
Okay, so you are saying we will always traverse right first, and whenever we are hitting a new level, that means we have got a new value.
Correct. And just add the first value. We don't need to add other values.
Okay, yeah, I think that will work. That can work. Is it clear to everyone how we are going to solve this by using DFS? So what we are trying to discuss is, let's say we started from here. We first go to the right part. We will check if we explored this depth or the level yet or not. If we have already explored this depth, then we are not going to do anything. If not, we will push this three as a right view of the node, as a right view, one of the value of the right view of this entire tree. Again, we will try to go to the left, which is 8. If this is the new level which we are traversing and we have not traversed it yet before, so again, this is also going to be the answer of the one of the things. I have one question here. Let's discuss that one. And again, we will try to go to again right, and that way we will not be able to do it. What if I change the tree somehow this way? Will you be able to fetch this 6 and 7 with this strategy?
Yeah, like why not? Because whenever we'll go to the sixth time, this will be the first time we are reaching to this height or this.
Mhm.
Then we'll only appending same for seven.
Okay. Okay. Is it clear to everyone? Or anyone have any doubt? So if you have previously seen the recorded lectures, or if you were in the lecture where we discussed how we can use the DFS to do multiple questions, we were just using one of the that strategy to solve this question. Okay. So, no issue. Last time, what we were thinking, what we were going to start next time, I forgot. Let me check. Let me check.
Like I guess we were thinking of starting BST,
Which tree?
BST.
Binary search tree. Okay, got it. Yeah, we can try. We can start with it. So as you guys know, what is binary tree? Now let's discuss about what is binary search tree. As the name itself says, does this name give you any intuition on anything? Like how this can be different from binary tree?
Like the name, like it is made up of two terms, binary search plus tree. So somewhat binary search is kind of innate in this tree.
Okay, if I say it that way, if you need to find out some particular node in a binary tree, uh, how many comparison it will require in the worst case? It number of comparison will be equivalent to the number of nodes present in the binary tree.
Right.
But in binary search tree, it's going to be log n, because every comparison we are making a decision and we are kind of reducing our search space. Let me tell you how. So in binary tree, there was no sequence or anything. I mean, it could be in any form that left can have bigger value than the root, or right can have lesser value from the root. But in binary search tree, left node will be always lesser than the root, and right node will be always greater than the root, or equivalent to root. You can say just it is that's how you can say. You can keep equivalent also here also or here also, just to at one of the place only. So this is the major difference between the binary search tree and binary tree. For example, this is a binary tree which I am drawing right now. Okay, but this is a binary tree BT. Okay, but if I want to draw the binary search tree, then it will look something like this. Now, if you want to find out any value, you always know when to go to left or when to go to right. Like if you remember in binary search, you were taking a decision at every comparison that hey, do we want to go to the left subarray or do we want to go to the right subarray? In this binary subtree, sorry, in this binary search tree, similarly, you are going to do the same thing. At every node comparison, you will get to know, hey, do I need to go to the left subtree or do I need to go to the right subtree? So that's how this binary tree and binary search tree are different from each other. Is this clear now?
Yes.
Okay. So you will see one more thing here. If you write the in-order traversal of binary tree, then you are not going to get anything any particular sorted array or anything like that. But if you write the in-order traversal of if you write the in-order traversal of this binary search tree, then you will get a sorted value. You will get a sorted array in order. What will be the in-order value of this binary search tree? In-order traversal value.
One, two, three.
So this is the thing. The in order traversal value of binary search tree is always going to be a sorted array.
Okay.
Okay.
Yes.
Is this clear to everyone? Okay. So there is nothing much in the binary search tree. Okay, if I ask you one question that you are given a binary search tree and you need to find out the kth smallest node, how you will find it?
Kth smallest node.
Correct.
Basically, we'll store it in order and then we'll return the kth element.
Okay. Is there any other way actually?
Kth. So, like in BST, it is guaranteed that we'll be having. How will keep track of index?
Think I'm not sure. I'm not saying if there is any possibility. I'm just saying think about it. What if we start doing the comparison? But there is one issue with the comparison that
On each comparison, we'll discard and buy two elements. So,
there is an issue with that. We don't know what is the size of left subtree and we don't know what is the size of right subtree. And we are looking to find out the kth value. We know everything is sorted out. But let's say when you entered the two, how you will decide whether to go to the left or whether to go to the right without knowing that what is the size of the left subtree and what is the size of the right subtree. Because by that you can't know where that k will exist. Whether that k will exist in the left subtree or whether that k will exist in the right subtree.
right.
So are you able to think of any other solution? Any solution?
Like the only solution is this in order one, but like somehow we don't need to store it. We can keep the count, like whenever I'm encountering in order term, I just increment the count and at kth position.
So you are saying that we will not complete the in-order traversal? Is it what you're trying to say?
Right.
Okay, yeah, that can be a little bit optimization. Okay, if I ask the question that I am giving you two nodes, you need to find out the space between them, shortest space between them. Yeah, that's a great question. Okay, we will talk about this today. A good concept. Okay, consider that I'm talking about a simple tree. Okay, but in binary search tree, there is nothing much there. Let's say you are given a tree. Let's say 2, 3, 5, 6, 7, 8. Every node is unique. Okay, unique nodes. For now, although it does not matter because the address is always going to be different, but still, you need to find out the shortest difference between two nodes. For example, in shortest difference between okay, let me draw a few things in that case. For example, shortest distance between 8 and 7 will be what?
One,
How it is one?
like the below node is 7 also.
No, the distance will be this, no?
But the node which is child of 8, that is also 7.
Sorry, don't consult, like as I said. Yeah.
Yeah, then 4, 1, 2, 3, 4. Yeah.
So this is what you need to find out. How you will find out this?
7 and 8. Okay. Like, is there a way that I'm only seeing a single path, like, with, and
No,
then this,
the issue is not how you will find that out part. How you will find that part. Don't think that there could be multiple paths. That's why the question is hard. How you will find this path? Just tell me that. Let's forget about the minimum path. Tell me the path only. How you will get the path.
like, at every parent, I'll return the minimum path from the 7. Like, at 3, I'll return
There is
the,
a issue. The you don't know where the seven exists and where the eight exists. So every time you are comparing for both.
like, in BST, we know, right? In,
This is not a BST.
okay.
Okay, so I mean with this two and three you can specifically get it because on the left it is bigger than the two, which is not a BST tree. Okay, since you have started with BST, let's say this is a BST tree, then how you are going to do it?
Uh, so, like, at 2, we know that. So we'll,
See, node can be anything. Don't take that. For in this case, you know there will be a chance now that both the values exist in one of the left subtree. Think in that way. How? Okay, you took the ancestor node, you took the root node. What is the first step which you are going to do? You are at 2 now. You have two values, 7 and 8. What is the first step which you are going to take in PS2? Actually, in BST, this is more easier question. Very easy question. In BST, this is very easy question, frankly. Are you there?
yeah,
Then,
like, in
okay.
BST, like, at 2,
Hmm.
we'll decide, at, like, 7 lies in left or right. We always need to go left.
Okay,
Same.
let me make a
Like,
BST tree of it. Otherwise, it may be confusing for you. Okay, so let's say 5, 4, 3, 2. Okay, now you can tell me. So 7, comma 8 are the nodes, and this is a BST tree for sure. Okay, I will tell you what to do. You will start with node. You will check it out. If both the nodes exist in the either side, either in the left subtree or right subtree, then you will do the recursion. But if you find out a condition at any node where it says that, hey, Smaller value exists in the right, big larger value exists in the, sorry, smaller value exists in the left, larger values exist in the right. So in that case, that particular node at which you did this comparison is going to be the answer. Okay, that is one of the condition. If, let me write this down, if at any node
We need to return the,
root,
so like at 7 or 8. Okay.
sorry, yeah, then you can find out the distance basically. I mean, that is one of the things which I can, you got to know. So this route is meaning that, hey, that the path will go through this node actually.
Right.
Okay, then what you will do, you will try to find out the difference between distance between root and south distance, and then root to 8 distance. You add both of them and you get the answer. But okay, if for example in this case we did the comparison at 5. Okay, let's start with them. Does 7 and 8 exist in either of the left tree? Yes. If they all of them, both of them exist in the right subtree, so we will go there. 10. Where does 7 and 8 exist? Are we seeing any condition where 7 is in the left and 8 is in the right?
No.
No. We came to 9. Here we have reached to this condition. Sorry, not this, that one, sorry. Not here all even again. Again, both of the nodes are in right, left. Here we got to know that, hey, left is in the 7 is in the left, and 8 is in the either right or equivalent. If you remember, I told you in binary search tree, it can be, you can use equivalent in either of the side. Here I told you, either you can use equivalent here or you can use equivalent here. Okay, that means you found that root node. Now the root node is 8. What is the distance between uh, root node and 7?
1.
What is the distance between root node and 8?
0.
Final answer 0. Now I will tell you what this root is called. This root is called LCA, lowest common ancestor. This is like various time asked in the interviews or the OS. Lowest common ancestor means you are given two nodes. You need to find a node in such a way which is common, which is the lowest common, which is the nearest common to both of the nodes. So that is what we are trying to find out in first step. Once we got that node, and then we eventually try to find out the distance. That's how we are getting the shortest distance.
Okay.
Clear?
Yes.
Now this we did in binary search tree. How we will find out this lowest common ancestor in binary tree? That is a little bit tricky if you have not done it before. Let's come back to the main question. Yeah. How we will find out the LCA, lowest common ancestor in the binary tree. Once we know the lowest common ancestor, then it's easy to find out the distance between both of the node and then add them, and finally we will get the answer.
I mean, at each node we have to um, look at both the sides.
Yes,
We are
we will
getting,
have to.
if we are getting a diversion, like we are getting both nodes, one in left and one in right, then that is the LCA. Otherwise,
How we will get to know that we are getting one in left and one in right? And it's not just about knowing that the root exists, it's about returning the exact root also. This is a very interesting question. We have already done this kind of question maybe when we were trying to find out the maximum path. Some the strategy is going to be same doing the post processing. Once we get the left and right, then the really fills will come. Okay, let me show you the code and see if you are able to identify how this thing is working.
Can we somehow return the paths of
We are not. The first step is to find out the node which is lowest common ancestor. Since we have already discussed how we are going to find this. Let's pick up any solution. Are you able to understand this code? So first two if condition are just on null checks or the edge cases or the corner cases or the base cases, whatever you say. Are you able to understand this code?
uh, so like initially we are checking if LCA1 and LCA2 both are not null, then the root is the
That is one of those conditions where one of the values in the left subtree and one of the values in right subtree. In that case, definitely you will return the node. Root node. Second condition is one of those conditions where uh,
left is the root. Right.
where the node is itself the child of the other node. In any case, for example, in our case here, this one 7 was a child of 8 node. It could have been direct child, it could have been indirect child. So in this case, LCA is going to be 8. That's what they are saying. If one of them is not equivalent to null and one of them is null, that means, hey, the other node was in the same subtree, in the one in which the first one was. That's why we are returning the LCA one. So either it could have been in the left one or it could have been the right one. That's what they are doing in the last two if else condition. Let me explain you some examples. Let's take this case. Yeah. We started at 2. We call left. We call right. Again, we didn't find anything. The first check, hey, whether root is equivalent to P or Q, nothing else happened. Again, a call happened this way and this way. From here also, a call happened this way and this way. Now, what this will return? What this recursion call will return? Tell me that.
Like 7 is equals to P this
So
time.
it will return what? Node of 7.
But
It will return 7 itself. What this 3 will return according to you?
uh,
It will again return 7. How? I will tell you. 3 left will return null because nothing is there. 3 right will return 7. Now let's go to code. 3 left is returning what? Null, which is LCA1. LCA1 is null. And in else, what we are doing, we are returning whatever we are getting from the bottom, which is LCA2, and which is in this case, it is 7. Clear?
Right. And like, okay. Like if
Okay.
that node doesn't exist in tree, then
The question says that both the nodes are exist in the tree. Otherwise, you will get a null at the end. I mean, the question says that the P and Q exists in the tree.
okay.
And if you are saying that, hey, yeah, those things are present in the tree, but they are not present in that subtree, then in that case, we are already reaching to the bottom and then we are eventually returning the null.
Right, right.
If you see one thing, there is only one point where the return value is getting changed, which is here. Otherwise, we are just following a chain of return. Whatever the child is returning, we are returning that, except in this case.
Yeah, like at
Okay.
whatever node we get, both the values are
Yeah.
non, that would be LCA.
Yes. Yes. So 2 left got 7. Now let's come back to here. What this 8 will return?
8,
8. What this 5 will return?
8.
8. What this 2 should return now? See one thing, left is also not null, right is also not null. What should be the answer?
Yeah.
That's how it is working.
Uh, okay. And in this algorithm, we will not, like, there is a chances that we'll not uh, traverse the whole tree. Like at 8, we haven't traversed
Yes.
10 because we just, okay. Okay, okay.
Yes. If in any of the branches we found out one of the node, we just backtrack.
Okay, got it.
And that condition is there's a base condition here which is written here.
Right, right.
So this question is clear?
Yes.
Okay. You will find multiple questions which are based on the LC, not directly, but indirectly you will somehow came to know that in multiple, I've seen it multiple OS question also, various time LC was used. So make sure you kind of do the practice of this very well. This is a very common question which are asked in the interviews or in the OS also. It will not come up directly, but somehow you will have to use it to get the answer.
Okay.
Okay.
So like for distance, like uh, can't we just return a pointer like at the point I found Q, right? I'll return 0, and on in the next node I'll just return 0 plus 1. And okay, then
No.
how decide at the root, like okay, we can keep a separate counter to count the distance in the parameters only.
There can be an issue with that one, no? That this is a recursive call. Are you going to use the counter for every recur? Are you going to use the counter which is limited to that particular call, or are you having a global counter? Because global counter will not work. But if you want to pass the arguments, then it will work. That is even also we I would have to think whether this will work or not actually.
Okay.
Okay, what you can do is, yeah, you can directly get the path actually. Instead of returning the LT, node, now what you can do, you can return one there. So you have returned this thing, na, return root here. Okay. Instead of this root, you could have returned one and you can represent null by -1. So you would have to do something like this. So if the return value is -1, that means nothing is there. If the return is 1, that means we need to add one more saying that hey, return plus 1. We have to do something like that to directly return the path to that LC actually. And then we can add it up.
Right, right,
But
right.
that can be done. Yes, it can be done. But you will have to little bit play with the notation. So you will have to represent null by -1, and then root returning instead of root, you could have represented by 1 or 0, whatever.
Okay.
Okay. Let's do one more question and then we will move on to the other part. Okay, let's try to do some OA question. One OA question from the lead code. Oh, that's not solved. It is just given in the path in the discussion. Yeah, try to read this question.
Like we have to maintain the same signature of the function, right?
Yeah,
Why,
I mean,
why,
signature is just an
oh,
input. This is an input function.
I mean, why this list of nodes is given? Like this isn't required, right? To
This
find
is required. This is required. In LCA, what you have done till now is that you were only given two nodes and you need to find out LCA for them. Here they are saying there is a list of nodes for which you need to find out the LCA. They are not just two nodes. It can be two, it can be three, it can be four, it can be five, it can be six, it can be seven, whatever, it can be multiple.
Okay, okay.
How you will solve this?
Like for each pair, we have to first find the
No, this is it's not. You can't do it with a pair. It will lead to multiple things. So, you are saying that you will take a pair of two, 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 and then combine. Then again, how you will combine the things? And that can be a think of anything else.
like so one thing what I'm thinking is that let's try this one with BFS. So I'll traverse each level and at whatever level I found any one of these nodes, right?
Mhm.
Okay, but then how will be, yeah, we actually we can pinpoint the exact node, the upper level, because at let's say level three, I found any one of these nodes. Then there has to be surety that either the that node has to be the LCA or yeah, that yeah, first time I found a yeah, yeah, yeah. No, just a
You are
second.
going in correct direction. Although I was not thinking that you were going to come up with this, but you are going in correct direction. Just try to think more.
Yeah, I'll say need not to be not to be in the list. So yeah, like one thing which
The
we can
issue,
say,
the issue with your solution was, let's say you find out even one node at any level. Okay, now we know one thing, that the answer is going to be coming from all one of the levels which is above than that level. Okay,
right?
but now how you will get to know
But,
from which
like
level it is coming?
not even above, like it has to be either in L minus one or LH level. Like
Not necessary.
it cannot be L minus two.
It not necessary. For example, if we check the last example of this one, yeah, the it was here. According to you, the answer should have been one of this one, but the answer was this one.
Yeah, right.
So how you will find out that which upper level is the part of this one is going to be the LCA for you.
Like other than that, one common solution would be like if we can store the paths of each node from the root, and then in all the paths, whatever be the first common occurrence, that would be an LCA.
We when we say LCA, it's more about lowest common ancestor, not just the common ancestor. There could have been multiple common ancestors. So how you will find out shortest one? What I've got is, so what we can do is we can start traversing upward by having a relation with child to parent by using the, so we will pick one of the list, we will pick the node from this given list one by one, we will traverse it till the root. Okay, you got out the path, then what? How you will find out the LC?
Like
LC is, mhm.
first we got all the path. Like first we got all the list with the paths. We'll start
Do we
traversing.
really need a list of the path? Because according to me, I don't think so. But let's say you have it, then what?
I mean, like just to simplify, like
You
I
are,
just compare.
it will not simplify it, it will more complicated. But let's say we have the path from the given nodes till the root, then what will be the next step?
We'll start traversing each list, but
Then,
that will be very
by the way, but you have already traversed it now. You are just re-traversing it. There's, until unless you're doing something different. You have already traversed it. You made that list on the fly. So if you are re-traversing it, you could have done the same thing at the time of the since first traversal also.
right, right.
Until unless you are using other information which you didn't have earlier. Okay, the way I'm going to do it is, first we can have a parent child to parent relationship. Then I'm going to create a hash map. In hash map hash map will have a key. Key will be the node of that particular path value. Let's say in the path 3 came up, 4 came up, so we will use that as a key. Their address as a key. The value would be two things. One is the count, and other one is the sum. Count represents number of nodes for which that particular node was part of. So let's say we are given three nodes for which we need to find out LCA. So there would be a chance that one few nodes are only coming in the path for two of the traversal, and some nodes are coming in all the traversal. So that count is going to store that, hey, in how many nodes that in that that how in for how many nodes that value is a part of, basically. The sum is going to be how much total amount of sum is going to take to reach that particular node from each node. It will represent the total sum. And whosoever is having the lowest sum with the highest count would be the answer.
Can you try it with a with an example?
Okay. Given nodes are 5, 6, and 4. My hash map. Key and value. As I've already mentioned, value will be comprised of two things: count and sum. Let's start traversing the path. Let's start traversing from 5. From 5, where are we going? 2, 1, and 1. From this to where are we going? 1, 1, 1, and what?
Two.
Okay. We have reached to what? The highest node. We can't traverse more. We are done. Let's start from 6. I should have added it. Yeah.
So when
6.
you say start from 5, you are saying just post order, right?
Sorry, can you come again?
So like whenever you say start from 5 or start from 6,
No, I
like
am
you
storing
are
the
going to pick,
parent-child relation. Are you tracking how we are traversing?
yeah, like you are going to pick one node at a time.
Yeah, I have already pre-processed the entire tree to have a child and parent relationship. So as we have discussed before, only parent know about their child, but I am going to create a hash map where child also know about their parent, which is very easy to create.
Okay, so it's a doubly linked
Hash
list
map,
tree.
kind
Yeah.
of, kind of. So we will have a hash map where you can say hash map is this one: child and parent. This relationship is stored in the hash map.
Okay.
Okay, let's start from 6. So from 6 we will go where? 3. From 3 where we will go?
One.
Okay, done. Let's start from 4. From 4 where we can go? At 1 only. Plus 1 again and plus 1. Now find out that key by traversing on this hash map where the given count is equivalent to the size of this given linked list, which is 3, and the sum is the lowest one. That's it. You got the answer. Typically for this one, as we can clearly see, the answer is going to be 1. I mean, it's very clear.
Right, right, right.
Okay, let's see what others
Let's
have
say
said.
we have a parent of one, let's call it 10. Then the sum would be for 10 would be like 3 plus 3 plus 2. That's why we are returning the least sum
Yeah,
value.
yeah.
Okay. Okay. Okay.
Let's see what others have said. Okay, what they are saying is they are using the same thing, but they are using the set here. That can be also done. So if you remember the simple LCA, we were returning at what point of time whenever we were finding anything, P or Q. So they will just check whether one of the values in the set or not. The same thing which you were trying to do the BFS, but in BFS that will not work because of the leveling part. Because it can be parent can be at L minus one also, L minus two also, L minus three also, and it's going to be hard to find that out. Are you getting this one?
Yeah, like so whenever we got like
This
any
one.
node which is in the set, then we are returning immediately.
Correct, correct, correct. So this can be also done. But we discuss the next different solution because this is also what you're going to also use in some of the question. Anything else? Yep. Same thing. Yeah, so I think she has used the ancestor part. Yes, he is using that part, I think. So we can check this out solution. Yeah, I think that's it. Hopefully this question is also clear to everyone.
Yes. But
Okay.
mm,
But
yeah, like but this thing like keeping this child to parent relationship was new in the tree.
oh, you will see a question where you will have to specifically do it.
Okay.
Okay. This should once you start doing more questions, this should automatically comes out from your mind that hey, you could have this relationship, you can have this one and all those things. So if you have even seen one of the questions, you will see one of the questions which are providing the list is where you have to create a connections between the level nodes, connecting this two like this, connecting this three like this. There's one more the question which is this also. So you will see multiple things there. Okay, and so move to the next part. Today we'll start some intervals question. Intervals question are those questions where we are given a starting and ending time, or where we are giving the starting time and the duration which is going to take for that event to get completed, something like that. So simple question. So you have a calendar, okay? You have a Google Calendar.
Okay.
If someone asks you to create a function so that you need to return all the slots which are free, how you are going to do that?
I mean like by slots, what you mean like the
Okay,
day.
let me give you the specific example. Let's say we are only talking about 24 hours. One of the meeting is scheduled to 1 to 2. Other meeting is scheduled to 12 to 13. Other meeting is scheduled to 15 to 19. Other meeting is scheduled to let's say 23 to 23.5. Other meeting is scheduled to 21 to 22.5. Now you need to find out these are your meeting time, existing meeting time. Now someone else also want to book a meeting with you, so he or she must be able to find a slot between your bit in your calendar. You need to return all those free slots which are there. For example, free slots can be 2 to 3 because there is no meeting from 2 to 3. Free slot can be 3 to 4 also because though there is no meeting from 3 to 4. So you need to return that slot interval, or you can say start time and end time to be more specific.
Okay, and like these meetings cannot be overlapping, right? These are discrete only. Like if I
Yes,
am
yes.
having 1 to 2, then I
They
cannot.
needs to be disjoint.
Okay. Yeah, then I guess we can just simply sort them
How? This is not a single array. This is a 2D array.
like on the basis of start time,
Okay,
uh, then start traversing the array and check if the like end time of the meeting is not equal to the start time of the next meeting. Then we have a slot in between uh, those intervals. So we'll
okay,
return the difference.
okay, and if you need to find out whether a particular slot is available or not, then how you will find it out?
Okay, now
You are
I'm
given your
with
schedules.
time.
Now,
Okay.
and in input, you are given interval. Hey, I am looking to book a meeting with this slot. Is this slot free or not?
Okay. So like initially, like first I'll see I'll extract all the free time, and if I'll see like my interval is
Not a
like,
better way. Waste of resources. Something better. Why we need to try to find out all the free slots when we are already given the slots and we only need to find out whether that slot is available or not.
yeah, one thing
Why
like
we are
we can do is that we don't have to check other slots. Like if my like someone has given me an interval from 2 to 3, then I need to just check till 3 only. Like there is no point of going beyond 3.
anything else? You can do more better. Don't you think you have sorted the array so you could do something better?
Binary search. Okay.
Correct. So
Yeah. But
can't you use binary search?
we mm,
So we can or we can't.
yeah, we definitely can. I think we definitely can. We just need to find the first closest uh,
So what is
closest
the issue here?
there can be overlapping with my interval and with that, like, so
So
I
that
have
is what you
start
need to
time
return.
with
No? You need to
one.
return true and false. You need to return true and false. Whether that slot is free or not free. Simple thing.
Right. uh, yeah, then let's simply apply binary search on the basis of start time. If my like the interval which is given to me, if its start time is less than the mid value, the end of the mid value,
Mhm.
uh, then it's not possible to book because I'm already in the meeting. If it is greater than, then I just need to check whether the mid plus one value start time is less than my intervals end time. Then it's free.
Okay. What if you need to ask to merge all the intervals? How you are going to merge all the intervals? So you are given a list of intervals. Some of the intervals are overlapping. You need to merge all of them. For example, the one of the meeting is at 2 to 4, and another meeting is at 3 to 5. So merging would be 2 to 5.
Okay. I guess like this was question was given as well, like when we solved this, like so, like first we'll definitely sort, then we'll use the stack. uh so like first I'll insert my first interval in the stack, and when the next interval will come, I'll just simply check if the start time of that interval is less than my stack's peak values end time. Then those intervals can be merged. So I'll just simply update the peaks and with the current end interval, and same for the rest of the array.
Okay. Consider that. Okay, let's do check some code. Okay, let's do this question. Yeah, try to read this question.
Okay. Yeah, got the question.
So what we need to find out?
We need to return true or false. Like we will be given with the interval
Mhm.
intervals basically, and we need to check whether any of the intervals is causing double booking or not. If it is causing, then
Okay.
return false. If not, then return true.
Okay.
And this thing will be given in a stream sort of fashion, right? This is not something which is already pre-given the whole thing, right?
No, you will be getting the start and end time as an integer only.
Yeah, like I'm saying about intervals, like we're not getting all the intervals
Yeah, this
initially.
is a string,
Okay.
kind of a string.
Yeah, then I guess we need to keep maintaining the sorted uh, slots,
How?
and whenever something comes, we need to apply like okay, how
How you will keep it sorted? Are you going to sort it every time? Because that's a bullshit one.
I think we will apply binary search on the like
I see issue there also. So if you apply binary search, then you will insert the interval, and inserting the interval will take big of it. Are we fine with that?
okay, inserting it also will take we have to shift things.
So how we can solve
One
this?
thing we know that okay, it's a calendar, right? So okay, so they are giving dates or hours. What they are giving? They are actually it's not
They are giving a number.
like if it would have been hours, then like the max value can go up to 24. Then we can create a 24 array, and then like at whatever interval we are getting, we just increment values in that interval. That sort of. But yeah, that's also not good.
Yeah, that could have been work if the intervals or the timing is limited. Can't we use set or map?
Set and map.
Mhm.
Hmm. I mean, it's an interval. Like, even if I'll check, like, some interval come to me, let's say 20 to 25, and I somehow stored all the start values in a set, and then if I'll check whether the
No, no, wait, wait. If it comes as an interval, you can say let's say the interval is 20 to 25. One of the value of the hash map, or sorry, one of the key of the hash map would be 20. One other key of the hash map would be 25. 20 can you can set 20 to plus one. You can set 25 to negative one. Whenever you want to find out the overlapping interval, just overlap on uh, just traverse on the hash map and you're done.
can you please repeat like what you just said?
20 to 25. 20 sets to 1, 25 sets to negative 1. Since we are using ordered hashing, every key will be automatically sorted out. Whenever you want to find out the overlap, start traversing the hash map, start traversing the ordered hash map, and do something like this.
Okay,
Some,
it's ordered.
if,
Okay.
I mean, that way you could have easily done it. So if you see at anywhere, at any place, sum becomes greater than 1, that means we are done. We got the overlap.
Like even in maintaining a ordered map is also like sounds similar to doing binary search on an array, because like when you insert a value in the
Not, no. So in insertion in hash map is different. They do it differently. They use internally. It's not equivalent to what we are going to do. So binary search will be logins, but our insertion was what?
our insertion was of O of n, that was the issue.
But we can cut it by using linked list. If you want to do it very code level, you can use linked list instead of array. And every linked list node you can store it in the map.
Oh, yeah, yeah, but doing a binary search on linked list is also
No, we are not using going to do binary search on linked list. We were going to do the binary uh, that thing on the in the map,
okay.
which is already sorted. So the thing which I've told you is called linear lines. I told you what I told initially. I forgot the line sweep line. Sorry, yeah. The algorithm name is sweep line algorithm.
Okay.
I mean, even though they are doing it same way, they are using that approach which initially we discussed: binary search and then insertion. Brute force. See, they are using the same thing. Sorted list plus binary search. The thing which we have discussed initially, but they are using this set of pair. And whenever they are inserting, again, you can say hey internally, but internally it's much lesser. Not all. Yeah. So as you can see, insert happens in log enter. That's what I was trying to say.
Okay.
Okay. But if you use sweep line algorithm, it will become much faster. Let me see if they have anyone I used it or not.
So like, what's the main idea of sweep line
Yeah.
algorithm? So, uh, so like the main idea of the sweep line
It
is
is just storing the corners. So it is just about storing the corners and rest using it with the pair of hash mark. It's the same thing which you are doing with that array actually, but in the compact way. So you are creating a long array. Na? What you are doing? Incrementing from 20 to 25. You are doing something like that way. Why we need to increment all the values from between 20 to 25? Why we can't have a boundary so that if someone cross the boundary, okay, you have a land. Now, if you want to say this is my land, are you going to do a boundary there, or are you going to put the brick in every part of the land just to say this is my land?
yeah,
Are
boundary
you there?
definitely. Yep, yep.
Yeah. So this is what we are doing here. So whenever
Okay.
someone enter into the boundary, they know what they are doing. That hey, we have entered into something.
Yeah, whenever they enter in the boundary, they are overlapping. Okay.
So it's like an entry and exit gate. From one way there is an entry gate, and from other way there is an exit gate.
Right, right, right.
See here.
Like every time we are getting start.
We will always increment start. We will always decrement end. Simple thing. If you want to say it.
Why we
Here,
are
if
doing
you see,
this, like always incrementing start and decrementing and okay,
how
it
you will get to know.
implementation. Yeah, let's see.
No, no. How you will get to know when something ended? So you will have to use negative value, no? Or some other notation. If you are not happy with that, you can use some other notation also. That is also fine. But it needs to be in the number format. So tomorrow we can know, hey, how many events ended at that point of time.
Right.
You can do reverse also. That is also fine. Replace and start with negative and then end with positive. That is also fine. They need to be opposite. Simple thing is that. So they cut each other. 1 minus 1 is what? 0. That means someone entered, someone exits. How many total person are there in the room? 0. Because 1 minus 1 is 0.
Okay.
And in the next one, which is for loop, they are doing the same thing which I told you. If whenever the count goes above 1, God, we are done. We found out the owner.
Can we like once do a dry run of this? Like I got the basic idea of the algorithm, but the implementation part, I'm not 100% sure.
Till now, till this point, what is total? 1.
One,
We will
right,
just add the value 1. So how many meetings are there at that particular point of time? It is 1.
right,
From 1 to 2, how many meetings are there? It is 1 only. Now at 2, how many meetings are there?
one. Basically, like one started, but the other one ended.
Yeah, 1. Correct. 1. 1. Again 1. Now from 2 to 3, how many meetings are there? Again 1. But at 3, 1 meeting ended. So how many meetings are there at 3 now? 0.
Zero.
3 to 4, is there any meeting? No. Empty interval.
Right,
From 4 to 5, there is 1.
right.
Now let's get back to code. So this is how we are solving this. Clear?
Yeah. So like whenever uh, in the loop we are incrementing the count whenever we like got an interval, and if it becomes greater than one, then we are having. So like if we go to our example, we go to example like the board.
Okay. Does you mean the whiteboard or the description?
Yeah, whiteboard. Whiteboard.
Okay.
Yeah, so let's say now I got a request to book an intervals, and I I got 2 to 4.
Mhm.
So like at 2, I'll just, so right now the value is 0. If we look at this, the
At 2,
pre-calculated,
it will be 1.
uh,
At 2, it will be 1, no?
like, so it's written -1 + 1, right?
But you will add the one first one also, no?
First one also. Okay,
See,
we
one of the meeting ended, one of the meeting started.
from here it's
That's
clear.
why
Yeah,
negative
like
one.
so
You
right now
can't
we are
directly
from
go
here.
to wait. You can't directly go to an integer to find out the number of meetings. You will have to start from the initial stages always to find out what has happened till that point. You can't say hey 3 is equivalent to -1, so there
Okay,
is
okay,
nothing.
okay. So it's a,
Okay.
it's kind of prefix some type of thing. We'll keep calculating.
Yeah. So if you see, every time we are doing a linear search,
Yeah.
even in the code.
Okay, 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 okay.
Okay.
Yep, yep.
Now they have solved it in another way. If I tell you, what they have actually done is they are saying let's book a slot and then check whether the overlapping has happened or not instead of checking later. What you were saying that hey, I will first check whether there is an empty slot or not, and then only book it. They are saying let's book it and then check if there is any overlapping happened or not, because you are never allowing to book a slot if there is any overlapping. So the existing array will be always correct. That means it is always overlapping.
So like if we can't book a slot, then we
They
might
are
have to
over.
avoid. Okay, yeah, they are
Yeah,
reverting. Yeah.
they are reverting the transaction also.
Okay, okay, okay. Yeah, isn't this a like complicated thing? Instead of we can just directly do it on the go.
You will get to know when you will write the code how which one is better.
Okay.
Finding the overlapping is much more simpler than finding a slot, because when we are finding the slot, you will have to do some corner cases check. A3 comes between two comes between whatever, and something like that, minimum, maximum. But to me, this like sounds like more simple and straightforward.
Right, right, right.
Okay.
Yeah. Uh, can you please share this solution in the link? Like, yeah, got it. Thanks.
Okay. Let's take a 5 minutes break. In the meantime, we can see whatever we have discussed now. If there is any question. Hey, hi. Am I audible?
Yes, yes.
Yeah. Is there any question till now?
No.
Okay. Let's try to do a few more questions. In that case, yeah, this will be more. Not this one. I think this one. Sure. Okay. Hopefully, this is not. Yeah. Okay. Let's try to do this question. Is it visible?
Yes. Okay, so we need to return the all intersections.
Sorry. Can you come again?
Like we need to return all intersections, right? Like whatever intersections are possible in the whole.
Correct. 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 Correct.
How this 24 comma 24, like, so one is ended and the other one is started just. So like we will consider this as well as intersection.
Yeah, so if it is given in the question, then yes. For example, this one at this point. So since the meeting started at 24, so this is an inclusive one. That means 24 is included. So if you see here, they have clearly said that this is an inclusive one when they say equivalent part. So if the meeting is from 20 to 24 to 25, the other meeting one is from 15 to 24. That means 24 is overlapping between the first list and the second list. That's why they are saying 24 to 24.
So like here we cannot use that sweep line because we have to return the actual intersections, right?
Yes, and no, I think let me think more, but let me think more. I think we can, but let me think.
Like one solution which I am kind of thinking of is like we can try something like what we did in merge to sorted list. So like let's say uh, I have a stack and I inserted 0, comma 2. I check that the next interval is okay. All that like in a list, all intervals are disjoint. So definitely, I'll go to the second list. I'll pick up the first interval. I'll see if it is mergeable or not. If it is mergeable, then yeah, then we just need to find the intersection. And okay, then how we will find it? Yeah, no,
Why can't we use C plan? Although it may not be, what if we use different denotation for the different numbers? So I can say, hey, we will use plus A and negative A for the first list and plus B negative B for the second list. That's how we can use the sweep line. So don't you think we can use the sweep line in that way? And every key would be having a hash array. So the key would be the number and the value will be the array of the list. Sorry, the list basically. Let's say if for example 24, 24 will be plus a and 24 would be negative b. So it's clear, it clearly shows if a and b is coming up in the same integer. I mean, according to me, we can use the free plan algorithm in that way, but we would have to maybe a little bit think more about the corner cases and how to find out those ranges also. But I think we can use it. But the other solution which you mentioned, kind of using the two merge, using the same method which using the merging the two sorted lists, I think that can be also worked out. We can do that also. So I will tell you what to do. Okay, I will tell you more better solution. Create a single list, sort it, and then do a single traversal and find out all the world. You can do that also. I mean, it's the same thing which you are doing. That, but that is also one thing which you can do.
like what you mentioned, like just create a single list, insert both the list and sort it, right, and then just see if
Yeah,
they interval.
because we, as they have already mentioned, that the individual lists are always non overlapping. So why to worry
Right,
too much about them? Or or we don't even need to do that. You can create a single sorted list by using the same method. This is a combination of two problems. One is merge to sorted list. First step to do that. Second step is to find out the simple thing, very simple thing. Find out all the overlapping from a given sorted list. That's it. We can do this question in that way. So, and we have already solved both the questions.
right, right.
So you will find multiple questions which you already know, which you have already solved, but that question involve just um, using the multiple patterns or multiple problems which you have already solved before. For example, in this way, one of them was merging to two order lists, other one was finding the overlap. So try to find, whenever you are solving those questions, try to find out the patterns from those questions which you have already solved before. That would make it more easy to write the code also and to solve the problem.
Right, right.
Is it clear?
Yes, yes. Like what if we have end list, then we have to just go with pairwise, right? Like first merge first two, then the result plus next one, the result plus next one.
Correct, correct. Let's pick another question. Okay, let's try to do some question which is merged up. Yeah, let's try to do this question. If you want to see any question which is kind of a premium question, you can use this website to see those premium questions and their solution.
Okay, leadcode.ca.
Yeah, try to go through this question.
Okay, so when we say minimum number of conference room required, that means maximum overlapping meetings, right?
That is what you need to think of. Yeah, so how we are going to solve this?
Um, like whenever our interval completely lies within an interval, then we don't need a extra room for that interval.
Can you come again?
Like whenever our interval lies completely within other interval.
You mean that is overlapping? I mean, basically it's overlapping.
Yeah, complete overlap. Yeah, like if there is half overlap, then still we,
Subset basically.
yeah,
Okay, one is the subset of the other one. Okay,
then we don't need an extra room for that.
why?
Otherwise, because like in
We
the
need
first,
it. Oh, we need it. Let's say the one of the meeting is from 1 to 10, another meeting is from 2 to 4. So you are saying we only need a single room? No.
like this,
Your first assumption was correct. We need to find out the maximum number of overlap, and that is equivalent to the answer of this question.
so like
Find
the
out maximum number of overlapping at any instant. So at one instant it can be two, at any instant it can be three. So you need to return the maximum. So yeah, that's the answer.
but like how
For
we
ex-
output is one in this case, like two to
which
four.
one?
Okay, uh,
So one meeting room to is will be required, no? Even if there is no overlapping, one meeting room to is required.
yeah, yeah, yeah.
Where will the meeting happen?
Okay, 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 okay.
For example, if you take example one from 0 to 30, whatever maximum overlapping is always 2 because 5 to 10, 2 overlapping, 50 to 20, again 2 overlapping. So max the answer is 2. In 2, there is no overlapping, so that's why the answer is only 1. Or you can say in example 1, the overlapping was only 1, so that's why we returned 1 plus 1. I mean, whatever way you want to code it.
Right.
So this is clear?
Like for the first one, there is an overlap this time, and then 15 to 20 is also okay. Yeah, it will two only. Like if there would be an interval, like if it's 9 to 20, the last one, then it would have been three, right?
Correct.
Okay.
You can use sweep line here. Or you can use your array part here that hey, we can have array increment. Again, whatever you use, it will work. Simple thing. Okay, and let's see the code. So this is the solution. He is using that thing, sweep plan. This is sweep plan. Hopefully he should have mentioned it. No, yeah. So he has mentioned it. Sweep plan and good.
He just simply first created the map and then he just took the max, right?
Correct.
Okay, like while taking max, what he is doing, while
Finding out the maximum overlap, maximum number of intervals involved at any particular instant of time.
okay, uh, like why this max line is required? Okay, okay, yeah, we can decrease. Yeah, yeah, okay, okay, got it. Right, right,
Also, there can be multiple overlapping. Na?
right.
So, but we need the maximum.
Right.
Okay, is it clear?
Yes, yes.
Okay. Any question?
Like this algorithm is definitely we cannot think of, right? It might be something which is standard, right? Like binary search.
So this is like a, I would say more like a compactness of that thing that we can have a fixed size array, then we can increment from A to B interval, then we can again if any interval come up B to C interval. So that way which you initially thought. So this is more compact version of that. There we were wasting the resources, and if we compact it, it will be the same thing which we have done with the hash map.
Right, right. We actually don't need to store the whole interval. Just the
Yes,
boundary will work. Right, right, right,
yes.
right.
Okay. Any other question?
No questions. Like, can you just go to that solution back? Like, has he maintained the sorted fashion?
Yes. See, he has used array here, but you should use hash map.
Okay. Okay. Yeah.
If
Right.
if it is limited, then use it because here it was given that it was only 10 to the power of 5. That's why he used it. Otherwise, even if you do the hash map, it will work. That's sort of trying to say.
Right. 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 Yeah.
If the input size is limited, if they are saying the interval timing is limited, then always use the array because it is going to be more workful in terms of runtime because every insertion can take a login time in hash map. But in this one, it's constant
Right. Right. Right.
if the input size is limited.
Okay. Okay. Mhm. Yeah. Got it.
I mean, this is also a kind of a map. If you remember initially when we started with hash map, I told you now that to convert how we can use ABC count frequency with the array only, converting the hashing the characters into the indexes.
Yeah.
So this
Like
is kind of a
mapping
simple.
zero day.
Yeah. Okay. Anything else?
No.
Okay. This is going to be the list for intervals. I will add it to the doc also. For if any of the question is premium, then I have already told you how to do it. I will also add a little bit more textual information in the doc. If so, for those who have not joined the today's session, they can know how to get those. And that's it. That's how we can do it.
Yeah. Sure.
Okay. Any other question? Any other concern? Okay, seems fine. Is there any feedback for anything we can improve?
Yeah, like I guess we are doing good, but like the only thing which is so like there are two types of hard question which I just encountered till now. One are those which are combination of a multiple concept. Like those are still understandable ki we can somehow able to solve. But some hard questions have entirely different concept, like which we never ever heard of.
For example,
Uh, for example, that rainwater trapping question was also like it was new. Otherwise, like although it was solvable, but at that time it
no,
was
I would tell you. No, I will tell you. So that question was much more intuitive to solve with the left hand prefix array. If you remember, I even
right,
started with that. Okay. But
right,
if we are specifically forcing to apply any pattern or anything, then definitely it will make it more hard. But why we are doing it? To make to have to get you the understanding that hey, how you can mold the things, whatever information you have to get your work done. So if you're trying to force something on any question, then it will make it very hard, definitely. But if you're trying to go what you can do their question, then you will not see it very hard. If you are saying, hey, I want to solve the question by using, let's say, for example, many of the questions are straightforward related to BFS. But if you have seen it, I asked you various times that hey, how you will do it with DFS, and you have seen that hey, it will be little bit extra things to do there. Think extra. So if you are saying that hey, I want to do it with DFS, then definitely you would have to think more, and the things may not be very intuitive until and unless you have thought in that way initially or previously. Because we have done it already, so now we know how far we can thought. So it's more about that. It's more about expanding your thinking angles, seeing the things in a different way, and that will help you to solve the question, more questions.
yeah, right. So like basically just to improve that thing, we have to solve
Yes.
a single question with multiple approaches, right?
Yeah. I mean, I'm not saying that solve it multiple, but at least see other approaches, see other how others was thinking of, how others were solving it. Because in today it may not be useful for you, but tomorrow in some question it will become useful.
Right,
Let's
right,
say if I am doing any question, I always go to discussion. Let's see how others have thought about this question, how in how many other ways the questions can be solved. So you should always try to have that thinking that hey, let me see how what are the other ways to solve this problem. Maybe I would learn something. It's more about learning.
right, right, right. Yeah, like yeah, like even that min stack question was like a very good example of this. Like we were maintaining two stack, but then we
Yes,
saw that we can try to like try to insert some sort of value which just uh, can return us the old value, old minimum value,
correct,
like that
correct.
sort of things. Those things like just feels like I'm not able to think of.
See, initially you will not be able to think of. It's like okay, you know the counting because you have been told before. It's like consider it that way that it's an entry path. Now you know the ABCD of everything. Okay, now you need to know how to make the words. That's what. Now you know ABCD. Now it's you're not able to think now even. Then that's the issue. Let's say about this thing of sweep plan. You didn't know it. Great, no issue. You learned it today. But if you're not able to use it later, I see that as an issue.
Right, right, right.
Not able to come up in the first go is not an issue. But not able to use it even after knowing it is an issue.
Correct. Correct. Yeah, like so it's all about familiarity, like how much familiar you are with
Yeah,
different.
first it's about familiarity, then it's about applicability.
Right, right.
Okay.
Yeah, yeah. Like
Mhm.
just this last question, like what would be the uh like what we will be discussing in the next session?
Uh, so after this interval, I was thinking we completed the binary search tree. I was thinking to continue on the graph part, start doing topological sort, Dijkstra, Bellman sort, and moving more on the graph part. Doing more questions on DFS and BFS till now. So till now we have not started graph yet. Actually, we were only doing everything on trees. Okay. Now we will start you doing the same thing with graph. So whatever BFS and DFS you have used, it does not only work with trees, it also work with graph. I will tell you the difference between the graph and trees, how to apply BFS and DFS in graph, solving some more questions using BFS and DFS for graph. So we are going to start with that. in the next session. Intervals we have, I think, mostly covered. I don't think so there is anything left specifically. Intervals question are very important for interviews and even for the OIS. So that's how I try to cover it. But yeah, I think we have mostly covered the intervals. I don't think so there's anything specifically left. So yeah, we'll start with that.
Okay. Yeah.
Okay. Anything else?
No.
Okay, I've already shared the list of the interval questions in the chat. I will also add it to the doc module, so I don't need to go this. Yeah, please try to do the questions because that is more important. Until unless you do it yourself, it will not work. So yeah.
Yeah, definitely.
Okay, then I think we can wrap up for today.
Okay. Yeah.
Bye.
Thank you for that.